It's go time do.
I've been testing to dance with my eyebrows.
I don't know that I have the eyebrow control. Clearly, I need to practice. And we really need theme music. So for all of you tens of thousands of people sitting at home watching this right now, send us some theme music.
Should we have like quarterly goals for our show? We could add
Are we sending
key result like of 10. Yeah. You run it like a whole like project.
Do you have a whiteboard? Because this is one of the things I didn't bring home from the office, but I need a whiteboard.
To like write the to-do list and like the goals. Yeah.
One of the engineers I have the privilege of working with has this interesting idea where they write out their to-do list on a whiteboard that just like sits publicly right next to their desk. It's great.
So I remember in the early days of Flutter, we were in some building that had walls that you could write on with chalk. And so at some point, someone covered an entire wall with like, okay, here are all the things we need to do to make Flutter work. And like people would walk by this wall and like their head would turn sideways because there's just so much to do.
Yeah. Anyways, you're going to kick me off into a rant about how to start projects. People don't know how to start projects.
No, you start a project just by doing it. But the question is, how do you like continue the project and turn it into something? It's like, well, you got to get organized at some point.
Yeah.
Like this show, like you go back to episode 1 of this show, like we had no idea what we were doing. Eric was just like, okay, let's turn on a camera. Let's make a web show. I was like, okay, let's try. We spent the entire first episode like trying to download like a Java compiler or something. Like it was.
That is true.
It did not go well.
I think we burned an entire episode setting up Visual Studio Code or something. But we still have no idea what we're doing.
It's true. We've just become exceedingly efficient at not knowing what we're doing.
So, hello, Dr. Barth.
Hi, Eric. How are you? Oh, welcome to Rubber Duck Engineering.
Yes, welcome to Rubber Duck Engineering. Love to have you. Tonight, we're going to do more crazy Ethereum stuff. Because why not?
Why not? The Ethereum world is very exciting right now. Like the prices are going up and going down, and everyone's all worried. But like, I just think the technology is cool. So we're just going to dig into the technology side of it.
Yeah. To be clear, like I don't know anything about the money side. I don't own the Ethereum. I'm not in this game, but I do think the tech is fun. So I know I've said this on past episodes, but the first time that we played with Solidity, however the heck I say that thing.
Someday we'll learn how to pronounce it.
Yeah, whatever.
I think it's called Ethereum. I'm not sure.
It was just so eye-opening, the idea of that a programming language could have money as a fundamental principle, or have keywords that were time, and just like it was just such a different approach. So
I think so. Last time we were toying around with implementing the Ethereum Virtual Machine, and we sort of got to run a toy program. And I think this week Eric had the idea that maybe we should try to compile some Selenium or Solidity, and then see if we can actually run that code, which I think is a really good approach to these kind of problems. I think of it as sort of an integrate first approach, where we could spend a lot of time toying around with building the VM, but it would be very easy to do that in a way that didn't actually work and didn't validate some of the core assumptions or implicit assumptions that we were making. But trying to connect it to the real compiler and some real source code means you can't hide from those problems.
Yeah. You and I are we're so playing tapes.
Well, I just thought like it may seem like if you're just sort of following along, you say, oh, okay, we'll connect it to the compiler, blah, blah, blah. But I think it's really important to draw out the point that this is really important in the course of a project, is to connect it or integrate it, because the integration tends to be the hardest thing. And it doesn't get any harder by waiting. And it doesn't get any easier by waiting. In fact, it tends to get much, much harder.
Yeah. And it drastically reduces your chances of, what's it called? Architectural astronautism or whatever, just like going off into the weeds. Like one of the things the viewers may not know, but like kind of your and my jobs both have a component of like teaching other people how to ship, teaching other people how to like bring new things into existence. So, and we're at least decent at it after all these many years. So shall we bring this terrible thing into existence?
Yes, let us bring it forth into existence.
Like Frankenstein. So full disclosure, I actually tried to go wild over the weekend, and then I bashed my head into the realization that I just cannot Rust to save my life. And I gave up fighting and decided to write a whole bunch of Dart code instead. Because I know how to Dart. No, it's funny. Like I fought with on my. I happen to have my Saturday mornings to myself because my family does other things. But I was writing. I was writing this because I was so excited about it. I was going to build out the machine more, and I just beat my head into the Rust problem enough times. I gave up. And then I converted somebody else's package to null safety, and I started a whole new project in Dart, and I wrote a whole bunch of screens in Flutter. It was great. So.
Yeah, there's definitely the learning curve on Rust definitely has the beginning part is very steep. It takes some effort to climb it.
So here we are. I also discovered this weekend why people don't like that Dart uses the bin folder for packages. Dart uses bin as the executable directory inside packages, which I guess Rust and other things have chosen as the build.
I see. It puts this output there, so they all smash together.
Yes. So this bin, I don't know where this pattern comes from, but Rust and others seem to use this. And so you will commonly end up with bin ignored in your git ignore, which conflicts with Dart. So
you want to walk us through what you did here? So I see there's a counter.sol.
So I was trying to make the simplest. Where is it? This. You can see I built twice. That's why. For whatever reason, the outputs for Solidity, they don't build based on the file name out. They build on the class name out.
Oh, interesting.
But so this used to have hello world in it. Now it has counter. So I could these files are dead. They're orphans. But why I got here was I was trying to make the simplest possible output. So if you look here, this is what hello world looks like. So this is the text representation of the hex of the output.
Okay.
The compiler output.
So this is hex, but in ASCII form.
Correct. It's a bit. I mean, I think it's ASCII form. I don't think Visual Studio is doing this for me. It's a bit wonky because they're like, here's this UTF-8 file with hex of your binary code. And it's funny also they give you several formats of it. Like it's also in this JSON. Like here's the bytecode, and it's somehow different from the deployed bytecode, which is like the stuff you send out to the world. And they give it. So like maybe we're supposed to use from this JSON file. I don't know.
Oh, I think when you deploy, what you actually do is you send a program that outputs your program.
Oh.
So I think it provides a little wrapper that prints itself, something like that.
So it's interesting also, I tried comparing my local compiler's output, which is using the Node compiler or the Python compiler, or whatever I happen to install for Visual Studio Code, to what they have on the Ethereum demo page. I'm forgetting what their name is here. It's in my little profile. This thing. No. Remix. This thing, Remix, which it looks like I lost my state, I think because Chrome crashed or something. But if you take, here it is, counter sol, and you compile it here, you do get slightly different output.
It could also be a slightly different version of the compiler.
I'm using the same, but I suspect mine is the JS one, and they're using some other different, because there's a whole bunch of implementations of this. Here we go. So if I do compile, and then I can show the compilation details, and here you get this giant JSON file. But if you copy this, and this is the you copy this and you paste it into, I think I did that. Yeah. So this is the paste of it from another run. So if you look,
disassembly too. That's good. Yeah.
Yeah. So I mean that actually would be a fun program, and maybe that's what we'll get to tonight. Is that it could be fun to write a disassembler for this. Actually, not sure if this is it. But if no, it is. Here it is. So I think this is the output. And another thing that this output does, which seems weird, is that you'll notice there aren't very many zeros in here. But at the same time, the entire language is all in 256. 256 is the 256-bit. Am I saying that right? Bit? Byte? No, it must be bits. Is just the width of everything in their world. That's like a word or a byte.
Well, I noticed it in one of those other files that you were showing. There were long strings of zeros and Fs.
Yeah, so I think there seems to be some.
Yeah.
There seems to be. Maybe it was this one. This one. Yeah. So this is an example where this I think is like probably the more full representation, and somehow, and I haven't read enough about the specs. They're allowed to, like, this is either because this file isn't actually used. I don't know what this file is for, because it's clearly like shortening some of the instructions to have fewer zeros.
I mean, my inclination here would be just to move forward, trying to parse it, and then try to like see if we can replicate that disassembly.
Exactly. That was anyway. So that's where I started in this thing. If you scroll through, we could look at what the git diff is. But let's see. I tried to learn how to. It was a journey to figure out enough of cargo in order to install this bytes subpackage. Because it turns out that the standard library depends on this. But if you want to use it yourself, you have to cargo it in, I think. I don't know. So I did. I don't know enough about Rust yet. And so then I managed to like read this. And reading as a string, that was trivial. Or the code that I copy pasted from Stack Overflow worked. I got this test. This test doesn't do anything, but it was an example of trying to understand how. And I got cargo test to work, so that was good. And then I was trying to write up a parser, and I, as you can see, I bailed. But I had difficulty figuring out how to get these bytes to be owned. Okay. So the problem, I should let you talk, but the problem that I had to solve is similar to what we had to solve in the HTML5 parser eons ago in C++, which is that you have this stream of int 8s, and you sometimes want to pull 2 of them. You sometimes want to pull 16 of them.
So what is bytes? Like, I'm not familiar with the bytes type.
The bytes type is int 8s. It's just a stream of int 8s, I think. It's a pointer to U8, the length.
Okay.
Creates a new empty. And as far as I can tell, the why I got to it is that, like, maybe it was this. Somebody returned me a bytes somewhere. And I was like, oh, that looks useful. I want to grab one.
I haven't used bytes before. I've used things like vex as like vectors of.
This thing returns a byte. This is the standard library right here.
I see.
Right? And it's returning this bytes. But when I tried to use it myself, it's like, you haven't declared bytes. And I was like, what do you mean I haven't declared bytes? It's in the standard library. But it's not.
I see. It's actually in this other crate.
It's in this other crate. I mean, I should find it in here. Or maybe there are 2 different byte types, but as far as I could tell, you had to depend on this other crate.
Okay. So from a like data flow point of view, it sounds like we've read the file into a string, then we've converted it to bytes, and then but we're still in like hex world, right? Do we want to convert it from hex world to binary world? What is? Do we write out like the steps that we want to try to do?
Let me try and get this thing to compile. All right, yeah. So we have to like read the string. We need to convert from hex to binary. That makes some sense. And then we need to read.
So we talked about last time we had this sort of structured representation for the bytecode. Maybe we want to bring that back, or maybe we just want to make a program that instead of executing the bytecode, just runs through it and prints it out, as opposed to transforming it into some other data structure.
Yeah, we talked a little bit offline about if this needed a lexer in front of it or not, and I think that I think we may end up with something more structured, because one of the things that we're going to have to include with that structure is like how many bytes after this opcode do you also need to like include as arguments for the opcode? Because otherwise you're just not going to be able to like read it correctly. But I wouldn't jump to that. I would do as you said. I would read it and like print out the bytecode.
Okay.
And so even that we could just build, and where we just print out 2 strings each.
I mean, that seems like a place to start. So you have fs read to string here. I'm curious whether strings in Rust they're like UTF-8 encoded as such. So I wonder if we actually want to read it to a string, or we want to read it to some sort of binary, more binary-like format.
Well, remember, it is a file of string. Right, so here's our thing running, and it just read the string.
I see.
Remember, because that's the weirdness of this .bin file. It's not actually binary. It's a string of hexed characters.
Okay. So contents, what is the type of contents here?
What is the type of contents? This is...
That returns you just a string. So contents is a string.
It is a IO result string.
Right. Okay. So naively, what I would try to do is I would try to split the string into 2 character chunks, because we think that each of those is going to be one
opcode.
One opcode. Like going to be 8 bits or whatever. I think string just has like a split method for doing that. That's fine. String docs.
Split n? Looks split n?
Yeah, split n sounds reasonable.
Split n. 3. Oh, no. This is so ugly.
There's also a right. The string has an as bytes method, which gives you back a slice of U8, which could also be a good way of working with this data.
Yeah, I mean, we also can just take them. We can take each character code and convert it. Like, each one is a standalone. Like, we don't need, in order to convert it from ASCII hex to bytes, we don't need to grab things in chunks.
That's true. We can just iterate through them.
But we do. This was the thing that got me stuck, is that, and this is why I wanted a parser class, is because you want to be able to say, hey, read the next 4, and then hand it back to me as a U32. And I didn't have I couldn't, in my limited Rust, I couldn't imagine how to do that.
So it looks, I just searched a little bit on this. I found a Stack Overflow article that says the I64 type has a from stir radix function that I think will do a lot of what we're looking to do here. So I think we'll want to use U8 or some other type.
But we still also need an iterator or something where you can say, give me the next 4. Like, they must have this type.
Right. Well, certainly if we get a slice, we can iterate it. I'm not sure if we can iterate directly the string. Usually iter things are called iter. Oh, so it looks like chars. On a string, there's a function called chars, which returns an iterator over the chars.
Okay. Does iter have a read the next 4 into this thing?
Yeah, the iterators are very. They have a ton of stuff on them.
Okay. So I can do var chars. Oh, sorry, it's let here in this language. Let chars. Contents.chars.
Yeah.
Okay. So I got chars. What chars? Let me do chars dot.
Right. So you can say take 2, which will give you 2 at a time.
There really is a ton of stuff on here.
Oh yeah, the iterators are very powerful. I'm sure there's a.
Okay. This is totally my jam here.
Yeah, I suspect that if we were Rust experts, we would know a better way of doing this sort of thing.
So sure, take 2. So let's actually just do this as a while chars that is not empty or something.
Well, you do the assignment inside your thing. So use a while let pattern.
Okay, while sum. Can I do that? While let pair equal or code hex code string in chars. I don't know what I'm doing. It's like.
So I want to ask. So last time we sort of jammed out a bunch of code, and then you got to the end and felt like you didn't really learn the language. So
That's okay.
I'm sort of hesitating to jump in and type things out here.
No, I actually think I just need to bathe in Rust more. Like, I can go learn a language. I just was too lazy to do it on Saturday.
Well, that what do you want to call it? Like code stir. Code equals chars dot take two.
Okay, so take two will eventually fail and cause the while to stop.
So I'm just looking at this. It looks like take actually just returns you an iterator over the last two.
Oh. Okay. So this is going to always return the same thing every time we call it?
No, it's going to consume, but it's giving us back an iterator.
Okay.
So we could do things like, I think we're trying to be a little fancy. So why do we just not want to go one character at a time?
Sure. But I really don't care how we do this. I don't have a code smell yet. Like, I don't have a sense as to, every language would do this a little differently.
Mm-hmm.
Anyways, so like, we need to, the very simple.
It's a map, right? We want to say let ops we want to take two. We want to map this, right? So give it to us one character at a time. It's not quite right because we want to unzip. I'm looking for a thing on the iterator that will like give me back an iterator of it, like giving me two at a time. Do you understand what I'm saying? Like,
Error string. Accept all the cookies. Yes, there we go. In string chars enumerate. Oh.
What is it?
Okay. That probably gives you indices, right? So the idea is they're grabbing indices and values, I think is what enumerate does. That's what it does in like Python.
Oh, I see. It just skips over every other one.
And then they're just pulling them out this way.
Okay. That seems reasonable. Should we try that?
Well, this was the questioner's way of doing it. I use peekable and take. What the hell is peekable?
Maybe peekable gives you an iterator that you can then call peek on.
By ref take collect. Whoa, collect. Intertools chunks.
Oh, chunks. That's got to be it.
Sort of. This isn't really quite. I mean, this would suffice for now, and maybe this would be fine for now.
Chunks sounds cool. So what is chunks?
So we're going to call intertools. What's this extern? Great.
That just means you're. I'm not sure. So
that was a great answer, by the way. Lead with confidence, and then you back off.
Well, does this compile what we have here? Like somehow mad.
Problems. Show me the problems. No method named chunks.
Oh, okay.
Presumably, we need
to import itertools or get. We just need to get itertools.
Well, maybe this will just work. Like, I don't know what this extern thing does. But you can't find crate.
Yeah, why don't we get rid of the extern thing and just try to add? Can we add iter tools to our cargo file? And
oh yes, we can. Cargo, add iter tools. This is what I fought with for a while. It turns out, there we go. It turns out cargo itself doesn't know how to edit the Tom files. And then you go and you read the bug that has like 100 comments on it. And it's like, understandably, I understand the reaction. It's like, well, somebody already wrote a package for that. Just install their package. But then I installed their package and waited like 10 minutes for it to like pull down and compile and, you know, grind its wheat and feed its cow. And
but eventually it bloomed into a beautiful flower.
Eventually. And so now I have the like what feels like table stakes level cargo that knows how to edit its own cargo files. The rants are like not just for the sake of ranting. I actually feel, I mean, Rust is way past this, but if I were like early Rust authors, I would want to hear me ranting because this is actually really useful to hear like a user with expectations rant about your choices. Anyways, I find that useful. You're saying?
I'm just curious whether this compiled now or whether it was still mad.
Doesn't implement debug.
Okay, whatever.
Well, that's really close.
I think we want to map. I don't know what we're going to get here.
It's right here. It just this. Whatever that one does. We just don't want the debug formatting. Map exists for struct, but its trait bounds were not satisfied. Unsatisfied trait bounds.
Okay.
What? This was clearly written by C++ programmers. Mute. Exists for struct, but it's trait bound. Should we go look and see what?
Sure. What are its trait bounds?
Ah.
Oh, the Windows menu.
Windows menu. That's what we need in our lives. Is more Windows menu.
I think I'm going to go to definition on chunks is getting into chunks. That's fine. But what is map?
Oh my God!
What to do? you got to do it.
I don't know what happened, but like Microsoft did its normal Tuesday restart of this machine, and now it wants to tell me the weather in the bar. And if I click on it, it like tries to sign me into my Microsoft account, and I don't know what. Whatever. Chunks. Yeah.
And it's going to capture that. Okay. So another question is, what do we do with this?
I think you can just print it. That's what this thing seems to. Oh, for C in chunk.
Okay. But for chunk in chunks, then for C in chunk. Let's just try to replicate that.
Why just copy it?
Sure.
The pasta is strong with this one. Right. If we just remove this and put. It'll just compile, right? Stack Overflow would save our souls.
Oh, sorry.
What? Expected. Iter tools is not an iterator. Help. The trait is an iterator, is not implemented for iter tools into chunk.
Okay. That's probably why map didn't work either.
Well, when was this answered?
They have like an ampersand there? Does that make it happier?
Oh, I see. When in doubt, add another ampersand.
I'm not sure.
What do we do? Oh, look at that. Except we're doing it by 3. We wanted to by twosies here. These are we're Noah's opcodes here. Yeah, there you go.
So what is chunk? Like what, can I just print out chunk directly instead of iterating it? What does that do?
It complains, doesn't implement display.
I believe that. But like, what if we?
Type annotations needed. Cannot infer type for parameter B.
Okay.
Do we need to pull that out into a typed thing? This collect. What does collect do?
Collect should like drain your iterator and give you back a vector. But ultimately, what I think we want to do is call this like from radix thing of some form. So I'm going to see like what radix from radix stuff wants.
Radix from digit. A digit to the given radix to a chair. No, that's not what you want. You want the other way around. Ooh, from bytes, from big Indian, from little Indian bytes, from stir radix.
Right. So I think this is ultimately what we want here, because our radix is 16, right?
Well, or we can do it 8, right? But, yeah, we have to convert it at some point.
Right. So we're trying to get a string out of this. So we kind of want to make this thing into a string.
You're right. It is 16. Sorry.
This is also a problem I have in Rust is all these things return very fancy types, and I don't know quite what they are. So like, what is chunk? Like, what is the type?
How does anyone learn Rust?
You have a friend who knows more Rust than you, and you talk to them. And,
I mean, like, there's like a smell here which feels familiar, and like I can imagine coming to this as a C++ dev, which I was for a decade of my life, and being like, "Oh wow, this is such a like nicer C++."
Yes.
But as someone who no longer writes C++ professionally, this is clearly like it just feels like it's a language that is targeted at a C++ professional C++ dev. It's like here's a better C++.
Yep. It feels different when you're sort of like in the middle of a big project because you figured out how to do all the things.
Yeah, you can go find the code that does that and copy it.
Right.
Yeah.
It's a little bit hard to write from a blank piece of paper, especially like we just grab this itertools package, right? And we're not friends with it yet. And so
hello, itertools. Nice to meet you.
Okay, so I'm not allowed to collect this thing. So I have this thing, is iterator that's going to return 2 characters, and I want to make a string out of it.
Know this.
Yeah, I bet there's a way of making a string from an iterator over characters.
For iterator, there we go, right here. See, collect. Produce a string instead of a container of chars. Need the inverse of chars. Collect is generic and can produce the string for you.
Oh, that's what it was trying to tell us. It was trying to tell us collect into what? We'll try to collect into a string. Sorry, I typed something in there.
Trait from iterator determines which elements you can collect into which kind of collection.
Oh yeah, they're big on traits. So maybe this should work.
I remember C++ being big on traits.
Oh, they've gone traits crazy. So I tried that.
Yeah, it loves you. It's like that compiles. I speak your language here.
Okay, great. So then we need to. What do we want? We wanted a op to be a what is it? A U8? Is that what we want?
U8. Sure.
So this is our string. Our radix is 16. Then we should be able to print out our op here.
And that should like go back to hex for us.
Yeah, this thing needs to go back.
Expected mute stir. More ampersand.
More ampersand. Insert more ampersand.
Apply the ampersand. Trait bound. Oh. Parse error? Lower hex is not satisfied? I see. We need to handle the error?
Oh. Okay. Right. What if it doesn't expect valid hex?
Yeah. Yeah. Now we're happy. I do like that. That part I like about Rust. Force me to handle them and then give me a nice tool to handle them with.
Yeah, so there you go.
What's this? It's missing the leading.
Yeah, I'm sure there's a way of in my format specifier saying you always want 2 digits, but
yeah,
the arrow is the thing. This thing is the format specifier. we can look up how to make a format specifier. But
yeah, I'm trying the C++ way, seeing if that worked. Oh, I'm so good. I think printf did that because like the 0 means lead with zeros, and this is gives me 2 digits.
Okay, great. Okay, so now I think there's a way of like now we want to turn this into a map, right? We want to say let ops equals. I don't know why we need the ampersand here, but maybe that was why our map wasn't working before.
What's the map for?
Well, we ultimately want to get a array of these things. Like we don't want to write this loop, right?
Why not?
Take our chunks, because then you'd have to create a mutable variable that was.
Oh, I see. You want to map all the chunks. You want to read out of the file into ops. Yeah. Because one of the things we want to do is insulate ourselves from the file format here, because it is weird the way, like, it would be very reasonable for their bin files to actually be binary.
Like, does that work?
Method map. Trait bounds were not specified.
Okay, so this is the problem we had before. We couldn't. Somehow this chunks thing gave us back a weird thing that we couldn't map over.
The map exists for into chunks with trait bounds. Method cannot be called due to unsatisfied trait bounds. The following trait bounds are not satisfied. This is mutable itertools into chunks, which is required by mutable itertools.
Okay.
I have no idea what this is trying to tell me.
So somehow the chunks thing and maps do not play well together.
Okay, so map chunks. Stack Overflow, please. Come on.
I mean, my instinct to grab for map is not correct, but usually map is how you do a lot of exciting things in Rust.
Right here.
Okay, so
I love the internet.
Oh, look, that's exactly.
Exactly.
This is exactly what we wanted.
Correct.
Okay, so let's try this again. So
this is why whenever you have a problem when programming, you take the error message and you insert it into a search engine.
Okay, so can we copy and paste this segment? Like what?
Well, this is the problem statement. We got to get to the answer.
Oh, they said this is the problem I ran into. Okay.
Based on group by.
Oh, slow down.
Into iterator, not iterator.
Into iter. Okay.
C format?
I believe that you have to go into iter. So into is a very common pattern in Rust, which means I had something, but please convert it, make it into this other thing, and consume it. So
temporary like, value drop by borrowed while borrowed.
Okay.
So we've got to let.
We have a comment from Nash that you should project.
Oh.
Hi,
good
Nash.
Developers copy, great developer space. Okay, I got it.
Nash. It's been a while. Thanks for coming back.
Nice to see you, Nash. I think I saw you at I/O this week, or someone else named Nash, but nice to see you. It's I/O week, by the way. I've been at I/O this week. It's been great. The Flutter tent has been hopping. I was at I/O. I was at I/O too. I saw you.
Did you see yourself in the I/O virtual world where everyone was crowding around the Flutter flag or whatever?
Oh, well, we had a Flutter tent, and it was great because it was just packed to the gills. But I/O was fun. They were like, I mean, it's not as fun as like being there in person, but it was like different fun because there were all these Easter eggs in the like I/O adventure, and one of them like required you to like edit the URL to like get out of bounds, so you can then like go to the out of bounds areas to get the like secret loot.
You like hack the game in order to do the thing. Yes,
we did. I saw you, and the Flutter tent was awesome. It was just it was packed. We had lots of people talking. It was funny. We I had a little bit of back channel that like there were some spam problems in parts, and so they had to like throttle the like chat rate down. But the Flutter tent, that was a problem because we had so many people trying to talk. We all kept hitting the like chat ban limits and had to like reload the page. So it was I mean, it's really hard to do. I have a lot of admiration for whoever put that together, because it's really hard to launch a product at that level of quality for that many people that's only going to exist for 3 days.
Yeah, you need to iterate on these products and like figure out what the abuse scenarios are and all those things.
Anyways, it's great to see you, Nash. Okay, so we were into ithering. Is that correct?
Yeah, it was complaining about something we borrowed and it was mad.
This is what we did here, though, right, Charles? I mean, if we do this, right, and then we do ops, does this help? So it's attempting to solve lifetime troubles. Yeah, okay, that worked. I just wanted us to like make sure these chunks stayed around longer. Maybe there's some way to do that with like a I don't know, dollar sign, or maybe a pound sign, or whatever Rust magic.
More odd characters.
Yeah.
Okay, so we successfully converted our hex string into actual hex integers.
Okay.
So should we try to parse them now? We had a match statement.
We had a match statement in our this thing, right?
So we just start writing that here, like for op and ops. Like we just want to match now, right?
Well, I think what we want to do, I think we should write a disassembler.
Okay. Do you want to do it so that it forms an intermediate representation, or just that it prints out the disassembly?
When you say forms an intermediate representation.
Basically, so we're going to go through, we're going to match all these things, right? And the question is, do we want to output another data structure, or do we want to just print something?
I think we just want to print something. I think the interesting part is going to be when so this ops is a problem, this current, because we have to end up working from an iterator. Because you do not know until you encounter the op what the next thing is. You need to be able to like turn the next few ops, skip the next few ops, right? And be like, no, that's my giant value, or whatever. Okay. Does that make sense?
Yeah. So you maybe we should collect this into a vector. Is what you're trying to say? You want to collect?
Sure. I do like this collect paradigm. This is nice.
Vector U8. And then here you want to iterate over for I in like 0 to ops.len. And you want to say let ops I. And then we can manipulate.
We can manipulate I.
Well, yeah, I think actually, I think this may not be quite right. Like we'll.
Well, why isn't it just for I and ops?
Well, that's kind of the same problem. That's going to iterate the we don't actually want to use a fancy iterator here because we want to mutate I.
I see. Well, this is what the enumerate thing was doing, right?
I think we just want to.
What?
Well, I don't think we actually want to enumerate that, because we want to, at some time in here, like for push, we're going to want to mutate I.
Yeah. We could do a while.
Right? Yeah, we can do a while.
While I is less than, I have no idea if this is valid Rust, but looks like reasonable Rust to me. I don't know whether Rust do parentheses. Share parameters without surrounding angle brackets.
Yeah, you don't need. It's like Swift. You don't. They did this because they force you to use the curly brackets.
I see.
Yeah. So we want to let mut I equals 0.
Oh, I see. Okay.
I don't know whether. So C++ I would do this.
For this, line 93.
Unknown.
So for those hopping in late, we're doing Rust the last couple, which I don't know at all. And Adam, I think your quip last week was that you have tens of days of professional Rust experience.
Yes.
I have tens of minutes of hobbyist Rust experience.
Is that is it mad about that? It doesn't like
well,
the
it's mad about 93. This generic parameters without surrounding angle brackets. I don't know what that means. Is that supposed to be? You're supposed to drop the angle brackets?
Oh no, more angle brackets.
Oh, more angle brackets.
More angle brackets. Insufficient angle brackets.
Oh, okay, there you go. Expected expression found plus. So this is.
I don't think plus is a thing. Like we have to do that and then say like. No, I don't think it has. I think we have to do plus equals.
All right, that's fine. Plus is kind of.
We want to do it afterwards, right? Like we want to read the op-out first.
Plus is kind of crazy pants, anyways. So.
Yeah.
So what I actually would rather do here is, so I'd kind of like to put this in a. Can I put this in a helper function? Does Rust have nested functions?
Yeah, you can just declare a function whatever you want.
All right, so say we did like fn print stir name.
The types go on the other side. You have to go name : stir.
What I basically want to do is I want to print out, always print the hex, because I'm doing an assembler here, right? Always do the hex, and then I want to do the name if we know it. Otherwise like unknown, something like that.
Oh, I see. So you want to do like a listing.
Right, because I want to show because then the other thing, the next thing we're going to do is we're going to do 02 name arg, right?
Right. So why don't we just do these manually for now, and then we can
it's fine.
Extract into a function later. So you want to do this, basically that, add, and you want to pass in op.
Yep.
So for push, we thought it takes an argument, right? So like it's going to have one arg here.
I think we can skip that for now, but like, yes, we have to. Oh, yeah, it's true. We could just do that.
So now we got to make this a multi-line thing. So we need to like take the arg.
Mm-hmm. Yep. Well, but this is real, right? That we have to.
All right. So let's make a function that's like. So once we have I here, why don't we make a let take equals let val equals ops.
What did you just write there?
The lambda.
Oh, that's a lambda. Whoa. Oh, I see. Because this is the.
Using a lambda will let us capture the
I.
After the I.
Okay.
And then we can just say let op equals take. And then here we want to say let arg equals take.
Yeah, this isn't quite right, but this is good. This is a step. Expected semicolon found keyword while.
Just
it's a lambda, so it needs a semicolon after it.
You want this syntax, right? You want this to say unknown like that.
Yeah, I would actually just put.
Okay. Does that fill?
No, we're missing expected identifier found keyword let. Oh, because we're missing.
Oh, we need the arrow here.
Oh, okay. Expected one of.
It needs to be a semicolon.
Yep.
It needs to be a comma.
Invalid format string found 2. You want the 0, 0, 2 comes before the X.
Okay.
Take cannot use I because it was mutably borrowed.
Oh, I see. This thing is going to borrow it mutatively. So we can have this return.
A new I?
Yeah, you want to do basically like if I is greater than or equal to, if I is less than ops len, and some else none.
I mean, as you remember from our HTML5 parser days, you end up wanting all of these functions to be on a centralized parser class so that you can centralize error handling.
Yeah, like this is eventually going to become our input, whatever we call it, the input management thing.
Yeah, this is the input stream, right? Exactly. That's what the ops is going to become, because they're not actually ops, right? These are bytes or whatever words, byte pairs, 16-bit or 16 byte. But take is also not quite right, because you're going to end up with 8 variants of take, right? This is currently take 2, and you're going to end up wanting a take 8 and a take 16 and whatever 2. What's unwrap?
So now this thing returns option. So when we take, we have to worry about the case where we're at the end and we're getting none. And so we need to handle this error. We're not set up to handle errors right now. We'll eventually need to put this into a function that returns a result.
Well, don't we just do expect val and hex? Or, expect and just be good.
I mean, it's unwrap is how you do this. Expect would be for a result. This is returning an option.
Okay.
Maybe expect would work too. Anyway, I don't know, but like
we'll handle that in hour 3 of Rust. Mismatch type expected bool found.
Sorry.
Okay. Cannot borrow take as mutable, as is not declared as mutable.
Mutable.
Okay, it loves you now.
Sure. You got me.
The Rust compiler is such a fickle friend. It's just like it goes from total hatred to absolute adoration.
I mean, the dream is that once it loves you, that your program is correct. Nash had a couple more comments. I don't know if you
Nash. Love the project name, Rusty. Yes. Why is it 2020 and there's still not a real clear built into terminals? Like when I go to the debug console, I have this, right? Which clears it. When I go to the terminal,
you can just type clear.
Well, you can, but it does the 1980s clear, which is like scroll it up. That's not what I want. The macOS terminal has this. Command K just actually nukes your buffer. This is what I want. Anyways, the reason why I want it is because I want to be able to easily find the start when I scroll up. Right.
That makes sense.
Right. So
we don't know very many of these opcodes.
That's okay. So supposedly this is the normal preamble.
Okay. Can we just look up those opcodes and start learning about them?
Well, exactly. That's where we're going to go. So our add must not be quite right? Because I thought we were going to print the.
No, add is it's push one.
Prints the thing. It's push one. And we didn't go push one. Love it. No push ones.
I mean, we're totally misparsing all this stuff, right? So we need to knock them out one from the beginning.
Well, but this is a huge step. So let's look at actual. So supposedly this leads with a push one.
But push one we decided was 60, right? And it leads with an 80. So maybe we just have to be able to process the preamble. Push one we decided was we probably just have the wrong numbers. We just labeled push one as 02. Should we look up the actual opcodes? This is what I was talking about at the beginning of the show, where you could live in this fantasy world where your code was just totally wrong and you wouldn't know for a long time unless you actually integrate with something.
And then when you live in that fantasy world, you can build on the fantasy, and you get into bad places when you stay away from the real world. So 60 is push one.
Okay, so let's try.
Add is 0, 1. Oh, this is just 60. Is it 60?
Yeah.
Hex?
Yeah, these are hex.
This is uint. Okay. All right, it's 60 hex. Okay. So let's see it. We should see lots of push ones. Okay, so we're seeing lots of push ones. 80. Love it.
Okay, so what is 52? I feel like we need a copy and pasteable version of these ops so we can just mass name them in our program.
I'm sure that exists. The other thing we can just get Visual Studio Code to do it for it, honestly.
Can we just copy and paste from this table?
Oh yeah, watch. I'm saying this way too confidently, but
it's all messed up.
You'd be surprised. Oh,
no, okay. I can try using the web inspector. Oh no, this is not going to work
well. We might be able to paste it into sheets, but I bet here we go. Let's get back to the Opera reference. This is the Go Opera's implementation.
You think that everyone in the universe would want to copy and paste this thing?
EVM opcodes. Here's somebody's.
Oh, here we go. I found that in a spreadsheet. If you go to the Ethereum Virtual Machine page that we were on, and you click on the opcode gas costs, boom.
Okay. Great. So we have to copy this.
I think we just copy columns A and B here.
Well, we need to swap them though, right? So we need to. How do I make a copy? Oh, I'm not signed in because I'm in my.
What? We don't need to make a copy.
Okay. Well, how do we swap A and B? Aren't we going to want names first? Whatever.
I just pasted it in. It's cool. It's cool.
It's cool. That's cool.
I created a lot of lines of, like 1,000 lines of empty tabs. So I'll delete here in a second.
You did it. Good job.
Now we're going to use the power of, I can't do vertical select. Oh, I can do vertical selection.
Because you want to. Not really. It doesn't. It hasn't updated my vision of yours.
Oops. Okay, so it changed down there.
I should also note we have 4 minutes left for typical showtime.
Okay, so
I would like to say that we've also exceeded my expectations. Well, we've met my expectations for the day.
Well, that's good. I'm just using this vertical selection editing tricks to.
Yeah, there you go. Good job.
Now, what am I supposed to say? Const.
Yeah, just right above you. Yep.
Or. So
you needed to do the instruction thing first.
Instruction.
Oh. Okay. Man, I'm impressed.
Vertical editing.
You missed a few.
Well, it changed formats here in the middle.
Yeah, it did.
So I'm just going to do those separately.
That's fine. But this is also, because again, we need to...
Oh, there's self-destruct. We found self-destruct.
Yes. I'm impressed. Your vertical editing mojo is quite...
Oh, yeah. This is one of the keys.
I see. This is the push star and the swap stuff.
We have to do those by hand, but we got the other ones.
That's fine. I'm going to remove this one. Okay. Perfect. Go. How do we have multiple Rust files? Because these really don't belong here. Well, whatever. It's fine. We can have a single Rust file for the moment.
Yeah. So I'm just going to try to add these to the thing. Or disassembler. I'm just going to do a big giant vertical editing thing to do that.
So, but I actually don't think you want them in there like that.
Oh, you don't? Okay.
Well, I don't think you end up. I think you end up with these in a separate file in an array, basically.
Mm-hmm.
And you do basically array lookup.
Okay. So I think that's too much for the last 2 minutes of the show, but maybe that's what we'll pick up next week.
Or I might do some of this weekend. Now that you've gotten me this far. Yeah. But let's show viewers what we've actually created. So we're actually reading from. So cargo run.
The output of the real compiler. So first of all, we took the real compiler, we compiled a real but trivial source code, and then we read that into our program.
Yeah. So this counters Sol, right? This when I save this or when I don't remember the exact mojo, but I think I compile this thing, compile contract F5. It now actually spits out. There you go. It just compiled this counter JSON, right? I don't know what this thing is. Yeah. Anyways, this bin was just created, was just touched by this. And then our Rust file goes and actually reads in that exact file, bin fixtures counter.
Yeah, it's cool.
And then we dump it out. If we run.
We started to disassemble it.
We started to assemble it. It's not perfect yet. But I think the next sort of big thing is that we're going to, as you started to here, we're going to have to add all the instructions. But I think we're going to have to add, like,
we're going to put some data in there, like,
more data to them.
Right. We should somehow annotate the push instruction that, hey, this thing takes one argument.
Exactly. And this is the argument.
The assembler should then read that data structure to do the parsing.
Correct. Because we shouldn't end up with like multiple pasted copies of the same stuff. Like we shouldn't paste it.
We should be looking up the opcodes in a table, then reading out their data and doing something with it.
Yes, exactly.
Okay. I'm totally on board with that. I think that's totally the right direction.
And so I think if I don't do some of that this weekend, who knows? Who knows what I'll do? Then that will be our next episode. Let me turn off the code machine so I can see your face. Anyways, this was fun as always. I think we made some good progress, and I'll push to GitHubs if people want to see our terrible Rust code.
Beautiful Rust
code. So yeah, again, all you many thousands of viewers, wink wink nudge nudge, send us a theme song so we can play a theme song.
Has to be like license appropriate. If you send us like a Madonna song, we're not going to be able to use it.
Yeah, or maybe I should pull one of my instruments off the wall and actually theme song.
Yeah, I mean, you've had the guitars in the background for every episode. Like, it's time to make use of them.
They got a little bit of movement because I was playing with my kid. My kid, I have a travel size guitar, which is the guitar that I actually learned on so many years ago when I was hiking the Appalachian Trail. I carted a little tiny guitar around on my back, and because you have free time at the end of having walked 20 miles that day or whatever, you sit around and do things. And I sat around and learned guitar. But I was pulling it out, and my kid, it was more their size. So, anyways, wonderful to see you, Dr. Barth. Any pizza updates for our adoring fans?
We forgot to make the pizza dough, and so we came to the day when we were supposed to eat pizza. We're like, oh, we didn't actually make the dough. So we're gonna try again next week.
Good. Well, we do look forward to the pizza updates. Well, you have a wonderful week.
Yeah, you too. I'll see you next week.
And we'll see you all next week. Good night.